Right, and good day and welcome. Topic 6 Functions or Graphs. Learning exercise 6.1. I'm just introducing to the function concept, elementary. Now, as a noun, a function can be described as any activity that is natural to or to the purpose of a person or thing. Mathematically, it can be seen as a relation or comparison or expression involving one or more variables, or a function in layman's terms is simply used as a means of comparison. Now you've learned already in grade 8 and 9 natural science, you've looked at dependent and independent variables. Grade 10 also with your practicals you have to write up, you have to identify independent, dependent variables. The main purpose of a function is to compare. So whenever you compare a Merck against a PM, you're actually doing a function, but you're doing it mentally in your brain. If we compare how much pocket money one gets in comparison to another one, function, right? So I hope you get the idea. When you compare, it's a very important concept that's in the world. Compare the markets, how this market is done in relation to something else, how does one thing affect another thing, etc. Then we're doing functions. So as a definition, we say a function is a set of ordered pairs where for every value of x there is one and only one value for y. However, for the same value of y, there may be different values of x. So I may have a lot of x values with the same y value, but I can't have one x value with lots of different y values. You follow? So we generally use functions to see how a change to one item affects another item. So we know if you change, your father earns more money, all of a sudden you get more pocket money. Father gets retrenched, all of a sudden there's less pocket money, less food, etc. So you see in the world there's always one thing that affects another thing. Now functions generally stem from various sources of info or data collected, and basically people are paid a lot of money to convert this into valuable information or data that can be used. They are called data scientists, data miners, etc. So if you like functions, you can actually consider a career in that. Right? So number one, first way we can look at functions is tables. We have an independent and a dependent variable. So in South Africa, you should know when you turn 16, you are required to have an ID to become a citizen of South Africa. Right? Independent is always considered my x-axis. Dependent is always considered on my y-axis. So you see x comes before y on the alphabet and ID. So you should know if we say give you a graph, etc., identify x value would be independent, y dependent. So look at your father's salary and your pocket money. So once upon a time, your father started working, was earning 15,000 a month, and he gave you 100 rand a week pocket money. As he increased to 20,000, he started to up your pocket money to 150, and so as his salary increased, you see your pocket money continues to increase. So when he got 35, he gave you 300 rand pocket money per week. So as salary increased, pocket money increased, which indicates what we would refer to as a positive relationship or as directly proportional. So when something's directly proportional, it simply means as one item increases, the other item also increases. Right? If you look at the second situation, one that you will do in grade 10, electricity prac, looking at current and voltage. Right? You can see there, my current there is independent variable x, my dependent variable is voltage. So as I'm increasing the current from 1 up to 5 amperes, right, my voltage decreased from 30 volts all the way down to 0.5 volts. So as one increased, the other one decreased. You see, 1 was 30, 2 became 15, 3 became 10. So 1, 2, 3 is increasing, 30, 15, 10 is decreasing. So as a current increase, voltage increase, which indicates a negative relationship, referred to as indirectly proportional. So when one item increases, causes another item to decrease, we say they are indirectly proportional or inversely proportional, depending what form of English you want to use. Sometimes you want to sound all on here. Right? Look at the second way we can give you functions. It comes in the form of equations, most of the time literal equations. So here if you look at the equation, speed equals distance over time, also annotated nowadays in grade 10 physics as v equal x over t. In this case, x is distance and not displacement, therefore v represents speed. So speed is directly proportional to distance, meaning that speed and the distance is directly related to each other, and it is inversely proportional to time. Right? So speed is inversely proportional to time. So you should note up in the equation, this item on my left is always directly proportional to my numerator, and it's always inversely proportional to my denominator. Right? Way of notating it, this simply means speed directly proportional to distance, x. This means speed is inversely proportional to time. So then we write time as 1 over t. Hope you follow. Alright, let's look at the third way. We do functions. It can come in the form of words. So you look at a barrel of crude oil. I assume you know what's crude oil. We import it from other countries and we convert it into paraffin, petrol, etc. Right? So barrel of crude oil is important at a constant price of $55 a year for the last 10 years. In 2008, $1 cost a South African R5.80, meaning for us to buy $1 we had to pay R5.80. And every year from there onwards it has increased roughly by 90 cents each year, up to currently 2017. So we construct a table to show the cost of a barrel per year. First and foremost, you note there we have a constant price of $55. That's referred to as a constant variable. So 2008 all the way up to 2017, a barrel more or less stayed consistent at $55 a barrel. My independent variable, meaning the money that I pay, $5.80 each year by 90 cents. So $5.80 plus 90 becomes $6.70. $6.70 plus 90 becomes $7.60. And so we continue increasing it by 90 cents. So basically what happened in 2008, it cost me 319 Rand to buy a barrel of crude oil. 2009, 368. 2010, 418. There, 2013, 565. And currently basically at that price and the Rand dollar exchange, it will cost me 764 Rand 50. So as you can see, from 2008 till now, the price of a barrel of crude oil has literally doubled for South African. So as the Rand weakened against the dollar, the more we have to pay for a barrel of crude oil. Now just to show you crude oil uses, it's just some of them. They'll have a lot of uses. We make petrol, we make transmission fluid, that's for power steering and so on. We make car oil, brake fluid, candle wax, paraffin. It's used in the production of tar. Take note, tar there, all of that is used up to 1.6 million a kilometer to tar, so quite a lot of money. So how can we use this information as a data analyst or data miner? Right? Basically, petrol costs me more to buy crude oil, so my petrol price is going to go up. Therefore, I'm going to pay more to import items to my country. Therefore, the people in my country has to pay more money to buy whatever they need to buy. Transmission, car oil, brake fluid, those are stuff that's used regularly in cars and are required to ensure that all the metallic parts are able to work with each other. There's no friction, doesn't cause fusion between the items. So without those items, most of our cars would break down. Candle wax, as you know, for religious purposes, and some people that still don't have electricity uses candle, and some people still cook with paraffin. So I also grew up with a small paraffin stove. Quite interesting pumping it. So you see, I can relate petrol to what happens to the Rand dollar price, can relate to what would happen for us to tar. So for us to maintain our tar roads, our infrastructure, it will cost us a lot more of money. Right? And then last but not least, we also have what we refer to as graphically, which is the main way we look at functions. So graphically we can compare there y equal to 2x plus 1, there y equal 10x plus 1. So as you can see, those two arrows I drew is just to show you the gradient. There's the change of y from this point to there. That's the change in x from there to there. So the change of y over the change of x will give me that 10IF. There, if I look at 2x, there's my change in y over my change in x. If I divide those values, it will actually give me 2. Right? There, if a graph goes from first to third quadrant straight line, we say it has a positive gradient. If a graph goes from negative or from second to fourth quadrant, it has a negative gradient. As you can see, as it becomes more negative, the graph moves closer towards the y-axis. Right? So that in a nutshell is functions. We have different types of functions that we will use. So you need to get used to and see this. If you don't get used to it, when you start interpreting, you get dear makar and you make error, and I don't want you to make error. Ne? So linear functions, y equal mx plus c, meaning straight lines. M represents gradient, x, c represents y-intercept. So the highest variable of x, if it's 1, it's a linear function. Quadratic functions, if the highest value of x is squared, then we have a quadratic function. There's example. Hyperbolic function, or the hyperbola or hyperbola, that is a over x. Here x represents a denominator. Then we have hyperbola plus q. Q there is just basically my horizontal, vertical asymptote. Right? Then we have exponential function, a times b to the power x plus q. So if my x is a exponent, then we have an exponential function, and there's an example. As far as notation is concerned, in equation format, y equal 2x plus 8. Function notation, instead of writing y, we write f of x equal 2x plus 8. If in mapping notation, we map it, f double colon x tends to 2x plus 8. In set notation, open x semicolon y equal to 2x plus 8. So that's just your different forms of notation. Now let's do functions. God bless, all the best.